I've been seeing a lot of interest in DNP3 protocol, so I wanted to talk to you a little bit about what DNP3 is and how you can use it in your environment. So let's start off with the absolute basics. What is DNP3? It is a communications protocol, which is really just a language that computers use. If you're familiar with Modbus or SNMP, you already understand the concept of what a protocol is. It's an agreed upon standard that different machines can use to talk to each other. It is commonly used in SCADA systems, and that's a key point. There really is no reason why a certain protocol has to be used in a certain environment, but certain conventions do get established within an industry. So whereas something like SNMP might be more of a telecom protocol, you'll see DNP3 in a SCADA environment, which could be a utility, wastewater, a water district, could be manufacturing, a lot of different areas, but SCADA has a general meaning within certain industries, and that's more commonly where DNP3 will be. What are some of the goals of DNP3 protocol? Really, like any open protocol, the number one goal, the number one reason why we have an open standard is because we want many different devices from many different manufacturers to be able to talk to each other. It's much simpler for you if you're trying to use a protocol when that's the case. If you buy a brand X device and it uses the special X protocol, good luck, because you're going to be trapped into just that manufacturer, and it really limits your flexibility in the future. Especially if that manufacturer goes out of business, now you're really in trouble. So an open standard is beautiful from that regard, because you're going to be able to monitor things no matter what manufacturer they're from. As long as they support DNP3, you know that one DNP3 device is going to talk to another. And there are four basic kinds of devices that we're talking about here that need to talk to each other. And those might be just general computers, any kind of workstation that needs to talk to something else, they can support DNP3. Then you get into RTUs, which are your remote terminal units. These are out at various remote locations collecting sensor data and equipment alarms, and they're dedicated to the monitoring task. They're going to take in maybe some physical inputs like contact closures and relay closures, and then turn that into DNP3 messaging. So they are a way of getting things that are not DNP3 supporting to have some DNP3 messages tied to them. Then you have non-RTU equipment that does support DNP3. This might be any kind of smart device in your power grid or in your wastewater system. It could be a pump or a generator, anything like that where it's got a little bit of brains to it. It can actually tie directly into DNP3. So you don't need to have a dedicated RTU tied to it. It actually has an ability to talk. So some devices will have that built in. And then finally your master stations. These are your central collectors. These are going to pull together information from all of those other devices and be able to put it on a screen. In SCADA terms, we would call this the HMI, or human machine interface, and it's just the central server. You need this in any remote monitoring environment because the whole point is that you're collecting data from many remote locations and bringing them up onto one display. So then where will DNP3 be used? As I hinted at earlier, it's mostly SCADA type environments. And really the original purpose for DNP3 back in '93 was for electric utilities, and they've used it extensively. But just like anything that's generally useful, you'll find that it gets into other areas. So water and sewage have come along, oil and gas, transportation, and really lots of other odds and ends. So you'll find DNP3 in a lot of different places. And some basic terms before we go much farther. The terms that are used for a remote device and a central master are key, and you just need to know what they are, and there will always be a pair of terms no matter what kind of monitoring you're doing. So in DNP3, we would use the term outstation and master. That's agreed upon in the protocol spec, and those are the terms that are used just for clarity. If you're familiar with more of a telemetry, a telecom environment, RTU and master station are commonly used. And then in an SNMP context, which is another type of broad open protocol, agent and manager. You have agents reporting to a central manager. So if you're familiar with those terms, you already get the concept. As you can see in the diagram, you just have multiple outstations and they're being managed by a single master in DNP3 terms. So when we talk about DNP3 communication, what kind of information is going on here? I should point out that DNP3 is typically polled, meaning the master will ask the outstation for information, but then of course the outstation will respond, and what kinds of things will it contain? I would break it down into three basic pieces. You have discrete information, so this is on or off, status, or okay and fail. So just what's going on out at the site, is it red light or green light? You can see my thumb up, thumb down there. That indicates a binary, either a good or a bad. So that's what a discrete is. Then analogs. This might be temperature, humidity, voltage, or current. Could be a reading from a sensor of any kind. Just something that has a value more than yes or no. It's actually an amount of something. So those can come in. And then counts, which are really just an analog. Some people will call them persistent alarm counters. And this is just how many times did a discrete toggle on or off? So how many times has a pump revolved? How many times has my HVAC cycled on or off? You can count up just about anything. So it's essentially turning a discrete into an analog by virtue of counting how many times it's happened. And now how about downstream information? So that previous slide was about what was going up to the master. So what's coming down from the master? Well, it could be control commands. You could be telling one of your outstations, do something. Activate this device, flip this switch, press this button, whatever it is, you can tell things remotely via DNP3 to do different things. And that is sending control commands. And then second, a more advanced control command could be set yourself to this value. It could be changing a temperature setting if you want to make an adjustment. So you're reaching out and touching a remote location so that you don't have to go out there and do it yourself. So DNP3 is important because it allows you to do a couple different things. You can view levels in real time and historically, and that could be, as I mentioned, temperature, humidity, battery level, fuel level, lots of different things you can monitor as an analog. And as you can see from the graph, you could look at that across time and see how things are changing, catch up with things that you may not be able to notice in your day-to-day job, but when you do your reviews, you could say, well, this is a little bit off. I need to make a change. So that can be a really important thing to do when you review your history. Of course, real time is probably the most important thing, and that would just tell you as you're doing your job, what's gone wrong, what do you need to go fix, and you need to know that within a few seconds of it happening, and that's what a monitoring system that could involve DNP3 would do. Then number two, once you know about that information, all those events, you need to get out and correct problems quickly. So it's a detection system that will then allow you to get out and initiate some kind of a fix. Whatever problem you've been made aware of, you probably know something about fixing it, or you can alert the right person. So that's a key function of using DNP3, is to be able to get out there and fix things before they really grow and get out of hand. You'll be able to eliminate bottlenecks and inefficiencies because a lot of it is just about moving around, especially if we're not talking about a factory, but you're in a power grid that's spread out across a large geographic territory. It's hard to cover that amount of ground. So just like any good communication system, being able to see what's going on out there is key because you're not driving out. And then furthermore, if you've got good information about what's wrong, you can show up with the right tools, send the right person. You don't waste a lot of time with confusion. It's just so much better when you have good intelligence. And ultimately, that means that you're going to be able to control a larger, more complex process, no matter what your environment is, without having to have an army of experts. Whatever team you've got, we're going to be able to multiply the force of that team using DNP3 protocol as the core of a monitoring system. And I think it's be a good time to zoom out and just talk about the four basic functions of SCADA, because I think I hinted to a lot of them previously. The first thing that SCADA does, whether it's using DNP3 protocol or not, is acquiring data, so pulling different sensor readings and other information out of various parts of your operation, and then communicating it back to you, which is using which protocol? Guess what? DNP3 in this case, and then which transport. Are we going to send that over network? That's the most common for DNP3 nowadays, but you can get creative if you have to. Then data presentation, how's it going to appear on your master? And then issuing control commands, which of course you do in your master station as well, and you're going to be sending those commands down to your outstations. So I want to get a little specific now. DNP3 tools, what kinds of things can we do with DNP3? So I've given a couple examples. These are from the DPS catalog, but these are not unusual. You can find these in a variety of places. So I hope these are helpful. So the first one we would look at is a master station. And I've described this, but here's a picture of our Timon, which does support DNP3. And you can take in DNP3 as well as many other different protocols using Timon. And this is just an example of how you can collect alarms. And then once you have that information, Timon puts it on a map, or you can get a list or send out email alerts or text messages. So any good master station will be able to do a variety of different things once it's collected information from a protocol like DNP3. And then you get into what's known in the protocol spec as a concentrator. And this would be a device, like I've used a NetGuardian here as an example, showing that it can collect alarms from different protocols. And we've seen a lot of this in the last couple of years where people want Modbus or SNMP or DNP3 to be collected by the remote, by that outstation device, and this is an RTU, and to be able to collect from those various different protocols and then report up as a stream of something else. And so in the raw concentrator function, we're not actually converting. In this example, you're just taking in DNP3 from different devices out at a location, and then the RTU, the Net Guardian in this case, is performing just a concentrator function. It's just going to send DNP3 up as a single device. It's perhaps done a little bit of muxing because different equipment might have sent alarms at different times, and it's going to just send it up as one nice clean stream of DNP3, but nothing had to be converted. And that's going to contrast with number 3, which is what I've termed an other protocol concentrator. So this is going to be collecting from different protocols that are not DNP3 and performing a critical translation function, because you may have a DNP3 only master, and that might be fine. But what happens when you end up with SNMP equipment or Modbus? I see this a lot in mergers and acquisitions. You end up with somebody else's equipment. How are you going to tie this together without having to have a separate SNMP manager and a separate DNP3 master? Well, as you see in the diagram, we can take SNMP into something like a NetGuardian RTU, collect Modbus using that NetGuardian RTU, and then have that RTU be set to report DNP3 up to you. So in doing that, it's essentially converted all the alarm data into something that you can actually use. So that would be perhaps a superior example of a mediating concentrator that isn't just pulling together DNP3 as we saw previously, but is actually converting other protocols into DNP3. This is a key insight, and I say this a lot. I really loved it when I heard this from one of our clients. You want to get started with your monitoring, because the further you get with it, the more things you're going to realize you can monitor and save money. So don't wait to have a perfect vision of exactly what you need. Find something that's going to be useful for you over the long haul. And DNP3 can be a big part of that because it's an open standard. So you know that no matter where individual manufacturers go in the future, you will always have options if you're using an open standard like DNP3. So get started, because the more things you learn, you're going to get started with a basic system, and you're going to be able to layer on and layer on and layer on. And a couple years from now, you might find yourself in a really good place where you have excellent visibility of your operation, and you're able to issue controls and maybe build in some automation. But that's never going to happen unless you get started with a basic system that has some expandability. So if you want to learn more about DNP3 or anything else that I've talked about, please subscribe to the channel, check out some of my other videos. And then if you'd like to, just give us a call, 1-800-693-0351, or send an email to sales@dpstele.com.